Hello everyone, I hope you're doing well. In this video we are going to solve a very interesting problem. This problem is related to finding out Miller indices as well as Miller-Bravais indices for planes and directions in HCP. Now these planes and directions are a bit technical and different from the ones that we have previously done, and I highly recommend you people to watch this video till end because it requires you to integrate all of the concepts and all of the techniques that you have learned before separately to utilize in the examples of planes and directions that we are going to see. Like, we will be using all of these techniques all at one place. By the way, this is a requested video and one of my subscribers requested me to upload that video, and I was very glad to see the problem because it was different from the one that I used to do. It's related to HCP, especially because related to cubic unit cells we have done a ton of problems that are all different, have different levels of difficulty, but in case of HCP I have never found any technical problem. Okay, so let's see the problem first and then we will dive into the solution. This is the problem, okay, and if you are comfortable with planes and directions in HCP, then you are perfectly comfortable with cubic unit cells and their planes and directions, because HCP coordinate system is a bit unconventional. That is not something that we typically deal with. We normally deal with cubic unit cells and 3D coordinate system that is a bit conventional. That is why students find it easier to grasp those planes and directions. But in case of HCP, it's something like uncomfortable for students, and one way to get rid of it is to practice as much as possible and practice problems of higher difficulties as well as easier problems, okay, so that you may get comfortable with it and you may solve any problem that comes to you, and you may score well in exam in that way. Okay, so let's see the problem stated and then we'll solve it step by step. Okay, first we'll find out the Miller indices and Miller-Bravais indices for the planes, and then we'll do it for direction. The problem statement says obtain the Miller index, M index, M means Miller, okay, obtain the Miller index and MB index. MB index means Miller-Bravais indices, okay, of the face. Face means planes or surface, they are synonyms to each other. So if a word face, plane or surface comes, then it means you are talking about plane. Okay, so we need to find out the Miller indices and Miller-Bravais indices. Both of these indices needs to be determined for the plane and directions. Directions are arrow marked as by these lines, okay, AB. Let me show you. This is AB. This is one of the direction whose indices needs to be determined. This is BC, another one, DE, EF, GO, and OK. Okay, so let's first understand the problem and then we'll solve it one by one. We can see there are the three figures. This is the figure 1, okay, this is figure 2, and this is figure 3. Okay, and we have three different planes here. This is one of the plane that I'm highlighting with green marker. Okay, all right, I hope you can see it. One of the plane that is shaded as gray originally in the image, and I shaded it with green, okay, in a rough way. So this is one of the plane whose indices, Miller indices are 3 indices, okay, that we can denote by H, K, and L. Okay, H, K. This notation is arbitrary. You can use U, V, W as well. So it's upon you that which notation you wanna adopt. So for Miller indices, I would use the notation H, K, and L. Miller indices are actually 3 indices only, while in case of Miller-Bravais indices, we have 4 indices which are named as H prime, K prime, I, and L prime. Okay, so there are actually 4 indices, and considering the 4D coordinate system, while in Miller indices we have 3 indices, and hence we consider a 3D system, 3D coordinate system to find them. So I was talking about plane, so this is the plane in figure 2. Okay, that was originally shaded by a gray line, so I'm shading it with red lines. Okay, this is the plane 2. And the third plane, if you don't want this discussion and you already understand the problem perfectly, then you can directly jump into the solution part. I will make chapters in the description box where you people can directly jump into your required area. And this discussion is important in my perspective, because understanding the question is half the solution. Okay, this is the plane 3. So we'll be finding out Miller indices as well as Miller-Bravais indices for these 3 planes. All right, and now let's see the directions. We have AB direction here. Okay, AB direction, we can see that we have some alphabets that are allocated to each of the corner points in each of these 3 figures, and all these alphabets are different to each other. Here it is A, here the corner is B, this corner is C, this corner is D, okay, this corner is E, F. None of the symbols are repeated. Okay, so all of these directions are different and separate. Okay, and K. Now AB direction, here they have shown it with a very little arrow, but there is one way to have an idea of how to draw a direction when the symbol notation is given. So it's AB, you know. AB direction means starting from point A and ending the direction at point B. So the arrow will be at the tail will be at the first point in order, which is A, and the head of the direction will be at the second alphabet here, which is B. So starting from A, so the direction's tail will be at point A, which is this, and drawing a straight line towards the point B and forming an arrow at point B. So this is the direction AB. Okay, tail will be at A because it's first in order, and head will be at B because it's second in order. And now let's draw the next direction, which is BC. So BC means starting from B and ending at C. So starting at B, this is my B point and this is C point, and yes, this is the direction from B to C. In figure 1 we have total of 3 things that we need to calculate. In figure 2 there are total of 3 also, and in figure 3 there are total of 3 also. As you can see, DE direction, this is D point, let me highlight it, this is the D point. Okay, starting from D and ending at E gives us the DE vector, just in case they have not mentioned it already. So this is DE direction whose indices needs to be calculated. And then we have EF, so starting from E and ending at F gives you that vector, and I'm making a very big vector in order to make it visible enough for you people, but okay, you just need to understand where these directions are located. I'm just making you understand the problem statement. This is GO. Okay, starting from G, this is the G point and this is the O point, so making a straight vector from G to O. This is GO direction, and then we have OK direction. We have this OK direction, so we have a plane in yellow color and 2 directions in red color, a total of 3 things to calculate in figure 3. So first I'll do it for figure 1, and now we are going to begin our solution in a proper way, and now we know what we need to calculate. Okay, so first we'll be doing it for figure 1. Let's begin. So here's the figure 1. We'll first find out the indices of planes for the plane in figure 1, then we'll do it for figure 2 plane, and then we'll do it for figure 3 plane. And after us finding out the indices, Miller indices as well as Miller-Bravais indices for planes, we'll find out the indices of directions for the 6 directions that are in question, one by one. Okay, so let's first find out Miller indices. Okay, M index. So first I'm finding out the M index, and then we'll find out the MB index, which is Miller-Bravais indices. Okay, so M index. So let me first mention the steps that are involved that you have to follow while finding out the indices for planes and directions. So the first step is to define the coordinate system. Define origin, okay, such that plane the plane doesn't pass through the origin. Okay, so the plane shouldn't pass through the region. That is the condition here, and we'll see there is a problem in the predefined coordinate system that we can see in the figure or in question. So we always have a predefined coordinate system in any problem that you are given with, for example. Okay, and there is a conventional origin that we always choose, for example, but that conventional origin doesn't work anymore in some cases. So first we'll do the inspection of origin, whether the plane under question passes through the origin or not, and whether the predefined coordinate system is okay for us or not, or we have to choose another one. So the first step is to define the origin. Second step is to find the intercepts. Okay, and since it's HCP, in HCP we have in HCP we have 4 axis lines. One is A1, okay, second is A2, then A3 and Z. Okay, and when we are considering a 3D system, equivalent 3D system, because we are finding here the Miller indices, so in finding out the Miller indices we consider 3D coordinate system, and the axis that we consider A1, A2 and Z axis are considered always in finding oh it's G at the end, in finding out the Miller indices for planes in HCP. Okay, whenever you are finding out Miller indices in HCP, whether it's for plane or for directions, the 3 axis that you are going to consider will be A1, A2 and Z axis. Okay, while finding out for Miller-Bravais indices you consider normally all of those axes, but A1, A2 and Z axis are the most important one. And since I'm finding out the Miller indices here, so that is why I will consider A1, A2 and Z axis here, and we'll find out the intercepts of plane to these axis lines. As you follow the problem with me, you'll understand what I'm saying. Okay, but I need to clarify those steps first because it's important also. After finding out the intercepts, the third step is to take the inverse. Take inverse, remove fraction if any. That's the fourth step. Take inverse of all intercepts. Remove fractions if any. If fractions appear, then you need to remove them. Okay, my first language is Urdu or Hindi, as you can say, so sometimes I just forget that I'm making video in, you know, in English, and I accidentally use those words. So that is one of the point. Yeah, these are the 4 main steps, and after that you get the indices, the actions, okay, the operations that you perform on intercepts obtained for A1 axis. You get H index for A1 operations, okay, for operations that you have done on A1 intercepts. You get H index from it, small h, and you get K index from A2 axis, okay, or A2 operations, and you get L index from Z axis, okay. So doing so, you will get 3 indices H, K, and L, corresponding to all these axis lines. And after finding out the Miller indices, I'll describe the procedure for finding out the Miller bravais indices, which is very easy. Okay, which is very easy for planes. So yes, let's do it for figure 1 plane. All right, and we can see here this is our plane, and there is a problem here. The predefined coordinate system has its origin just here, just at this point, and this point is common to the plane also. It means the plane is passing through the origin. The sentence that the plane is passing through the origin is similar to saying that if the origin and plane, if the origin point is on the plane. That's a simple word to say. As you can see, here is the origin, this is the A. Oh my god, the type of diagram drawing I have. Okay, so this is the origin, okay, the centermost point, and this line is the A1 axis as they have predefined it, okay. And this direction, this horizontal direction from origin to this corner, okay, this is A2 direction, and this vertically upward, straight line vertically upward, they have defined it as the z-axis, and this common intersection point is origin, and you can see this is a point on the plane also. The origin they have defined is lying on the plane, and this is not acceptable, okay, and we have to redefine the coordinate system, and we need some other origin here now. And for that purpose, what I'm doing is I'm choosing this point over at the roof point, okay, this center point just above the previous origin. This is the previous origin, this line, this cross one, okay, this is the previous origin, and I am choosing this centermost point, okay, at the roof plane of this HCP as the center of Earth, as a new origin, okay. And this will be a new region, and let me draw the new coordinate system now, and we have to forget the previous coordinate system now. And yes, let me define the new coordinate system, and yes, this is the origin point. They have, okay, this is the origin point, and you can see that here is the plane in gray lining, and it is the origin and the plane are separated. Origin is not lying on the plane, so our first condition is satisfied, and now we can define coordinate system. This is the origin, and this corner. Okay, if we mash both of these corners together, we'll get A2 axis, new A2 axis, this direction. Okay, this is a straight line. Try to define. Okay, this is A1 axis. This is another corner right above the one that was previously defined. This is A2 axis. Okay, and Z axis is simple. This is simply this vertically upward. This is Z axis. Okay, these are actually the perfect straight lines. Try to define try to make the perfect straight lines. It's better. Okay, all right. Now we have defined our coordinate system. Now the next step is to find out the intercepts for A1, A2 and Z axis, because we are finding out the Miller indices. So we have this axis line A1 and this axis line A2 and this axis line Z axis. Now one other thing that we can do is, now this direction, this one is positive A2 direction, and a vector just opposite to that, this corner is just opposite to this corner. Okay, drawing a line from origin to this corner will give you the negative A2 axis. As we have seen that this is the positive A2 direction, and this one, the corner just opposite to the corner will correspond to a negative axis. Alright, so that should be clear to you people. As let me show you one more thing, is now this corner of A2, as I'm highlighting it by a green dot, a very big dot, so this is corresponding to a positive A1 direction. So the corner just opposite to this corner is this one corner. Okay, and if we draw a axis line from origin to this corner, it will correspond to negative A1 direction. I'm making this clear to you people so that you may have an idea that how axis directions are drawn, and not always the positive directions are handy. You need negative directions also. You should have a knowledge of all the directions, all positive directions. Now let me show you the A3 direction because it's important here. Okay, so let me choose a suitable color. Let me take it. Okay, now this one corner, now let me show you how these things will work. Now this one is this is one of the corner for A1 direction. Leaving this corner untouched, we'll move to another corner, which is this corner. It will correspond to A2 direction. Alright, then leaving another corner again, the corner next to that one is this one corner, and this one corner will correspond to the positive A3 direction. Okay, the convention I showed you right now is for positive directions. Okay, and all other all other corners that we left untouched corresponds to the negative directions, and negative directions could be drawn very easily, so there is no issue for them. We first need to identify the positive directions. So you can see here that K So not that. All right, now this is nice. And okay, so this blue line is positive A1 direction, leaving in the corner, this one corner untouched. We'll move to this pink line, which is corresponding to positive A2 direction. Then leaving another corner untouched, we reach to the other corner, which will correspond to the positive A3 direction. So we got 3 positive directions, and negative directions could be obtained by simply extending them in the negative direction. So for A1, we produced it, we found the opposite corner, we have drawn a line from origin to that corner and got the negative axis. And now this one corner, okay, is for A3 and positive A3. The corner just opposite to that one is this one corner, so it will correspond to negative A3. So from origin to this direction. I am mentioning this detail here for you people because this foundational detail will help you to solve all of the problems that we'll be seeing in future. Okay, in future means later in this video, to solve the problem. So that is the foundational knowledge, and I have described that method well before in the videos that I have done before, but most of the students are watching the video for the first time and they doesn't know that. So if you already know all of these conventions, so you can skip it, but don't complain me for adding all of these details and making this video very lengthy, because I am not satisfied when I'm not telling you people all of the details that you should know, because it's very important. And now you have that knowledge that how this coordinate system is built in HCP, and this is very important. And from origin downward will be the negative z direction. Okay, and you can extend it up to this center point. Okay, because that center point is just below the origin, this one origin, the new origin, and the z-axis perfectly passes through both of these points. And yes, this is our complete picture. One direction, positive directions are mentioned, negative directions are also mentioned. Why I mentioned all of these directions you will see when I will be finding out the intercepts corresponding to A1, A2 and z-axis here. And let us start the process of finding out the intercepts, and I'll be finding out the intercept for A1, A2 and z-axis first. Okay, and for planes there is a equation that is true no matter what. Okay, so for planes, we have this equation that h plus k plus I equals 0. Okay, now this equation is true in all the cases. In case of here, if you talk about the 4 index system, H we know corresponds to the Miller index that we'll obtain for A2. Okay, and K corresponds to the Miller index that we'll obtain for A2, you know, that we will obtain from A2, and I corresponds to a Miller index that we will obtain from A3 axis. Okay, so if we know the Miller indices of A1 and A2, which are H and K, then we can find out the Miller index for A3, or vice versa. You know, if we know K and I, then we can find out H, and if we know H and I, we can find out K very easily. So most of the times, two of the indices are easily determinable from the figure because they are very clear, but one of the index may create problem, or it is wedge in the figure and we are not estimating it easily, so we use this equation. This equation helps a lot. Okay, so yes, we'll be using this equation later in the video. I just mentioned it earlier so that you may people know that you can use this equation. Now let us find out the intercepts, and what we'll be seeing that intercept refers to a point at which the plane touches the axis. Okay, so A1 intercept will be a point where the plane is touching the A1 axis, either in negative or positive direction. Okay, so let us first see for A1. Okay, because yeah, so this is A1 direction. Okay, and for your knowledge, I would love to mention that this direction is also A1 direction. I mean that they are parallel to each other. Okay, this one direction, this is A1 axis. Okay, and this direction is also in the direction of A1 axis, and this is also in the direction of A1 axis. Okay, you can see that three of these lines are perfectly parallel to each other, and this line, the third line that I have drawn this, this line is a part of the plane. Okay, so what I want to say is that the plane is parallel to the A1 axis. Okay, because one of the main boundary line, these are the boundary lines of the plane. Okay, these four lines are the boundary lines. For now we are considering these two. Okay, alright, so these boundary lines are perfectly parallel to A1 axis. That is why the A1 intercept will be infinity. Okay, there is another way to confirm that if you are unsure about it, so I'll mention the other method also. But for now, A1 intercept, you will take it infinity because parallel lines never meet and they will never intersect. Hence, the plane and the A1 axis will never intersect, for the reason that the plane's boundary lines, whenever you want to see whether a certain plane is parallel to any of the axis, you have to see the boundary lines. If obviously always two boundary lines will be parallel to any of the axis you are looking at. Okay, so here we were considering A1 axis, and we can see the boundary lines of the plane under study is parallel to the A1 axis. So that was very simple. Now considering A2 axis, we are finding out intercepts here. Okay, these are not the final indices. For finding out the indices, we need to do some other steps. So this is IN. Okay, it's not R. We are finding out intercepts here. Now considering A2, we have plane right here. You have to consider plane. Okay, highlight it in your eyes. And the axis line, we can see the axis line of A2 these are the axis lines of A2. Okay, this is, that one was negative direction, this is positive direction. We can clearly see it is not touching, the plane is not touching the positive A2 axis, it is actually touching the negative A2 axis. And we can see here this is the negative A2 direction and the plane is touching the A2 axis, negative A2 axis at this point. Okay, and what is this point? Always remember that from origin to the other corner of the unit cell, we take it as unit 1. Okay, if we if the plane, I'm just guiding you people that how to take values. So if the plane is touching at the middle point, okay, from corner to the origin, just at the middle point, if it is cutting at the middle point, you will take it as half. If it is cutting at third part, you will take it as 1/3. If it is cutting at the other corner of the unit cell, then you will take it as 1. And you can see here that it is negative A2 direction, that is why you will take -1 as the A2 intercept, because the plane is touching or cutting or intersecting the A2 axis in negative direction at the corner of the unit cell, so it will be taken as -1. So -1 is the A2 intercept. Now let's talk about the z-intercept. So for z-intercept, we can see here, you need to first see the plane. Here is the plane, okay, and alright, so we can see clearly that at this point, clearly the plane, this is a point on plane also, and it is the negative z direction here. This is the negative z direction. Let me take some other color so that you people may find it easy. This is the negative z direction, and you can see here that z-axis is touching the plane at this point. Okay, this is something that we have discussed before also. So this is origin, okay, and this is another corner of the unit cell. So we will take 1 as the point where it is intersecting. Okay, we will take 1, and since it is negative direction, you will take -1 as the z-intercept. I hope this is clear to you people that how I am taking these intercepts. Intercepts are actually the points where the plane is touching the axis lines. Here the axis lines are very important. You have to see where the plane is cutting the axis lines, either in negative or in positive direction. Alright, and always start with the simple ones, the ones that are clearly recognizable. A2 and Z were very easily determined, but for A1 you had to consider some other things. Maybe A1 confuse you, so yeah. So yes, we have got -1 as the A2 intercept, A1 intercept was infinity, and Z intercept is -1 again. And now we have to take inverse of each of these indices, and after taking inverse, now it's time to take inverse. Take inverse or reciprocal. So I'm taking reciprocal right now, and here is A1 intercept. Here I'll write the A2 intercept, and here I will write the Z intercept. A1 intercept was infinity, taking inverse of infinity, 1 over infinity, and we know that 1 over infinity is equals to 0. So 0 is something that we got as a result, Then we have a2 intercept, which is -1. Okay, so okay, let's take inverse of -1. We are taking inverse here. So inverse of -1 is again -1, so doesn't bring any difference. Taking inverse of z intercept and taking inverse 1 over -1 is again -1, so we got 0, -1 and -1. And since there is no fraction involved, if it would have been 1 over 2 in one of the places or in two of the places, we would have to multiply the LCM of denominators by each of the index in order to remove that fraction. So in that case we do not have any fractions, so these are the final indices, final Miller indices for the plane that we are given with. So for A1 we got H was equals to 0. For A2 we got K was equals to -1, which we can write as 1 with bar over it. Okay, and for Z we got K, oh sorry, for Z we got L, which is -1, so 1 and a bar on over it. Alright, and we can write them in complete form as by using the circular brackets like that is equals to 0 for H, 1 bar, 1 and a bar over it. This is the final result. Okay, for I know this is the final result for the Miller or M index for the plane 1 in figure 1. Okay, we got it 0, 1 bar, 1 bar. These are the Miller indices. Now let's find out the Miller-Bravais indices for the plane, which is super easy. Okay, there are the two ways that you can adopt, and let me tell you the easier one first, because it's up to you which method that you want to follow. So now we are finding out the Miller-Bravais indices. In case of plane, for H I mean Miller index, for H prime I mean Miller-Bravais indices. Okay, I'm just differentiating them by the prime notation. So in case of plane, H equals H prime. Okay, K equals K prime, I, let me put a prime over it to differentiate. Okay, I prime that I will mention at the end. Then we have L equals L prime. What it means till now, we'll talk about I prime at the end, that all three indices, all three Miller indices are equal to the corresponding Miller-Bravais indices. Okay, there is no difference at all. There is no difference at all. And we have one additional index, which is I prime here in Miller-Bravais indices, which differentiate it from the Miller indices in true meaning that in Miller indices we have 3 indices, in Miller-Bravais indices we have actually 4 indices. So we have to find out the fourth index, and this I prime is obtained from the intercept of A3 axis. Okay, so there are the two ways you can do it. I prime can be obtained from these H and K values, like it is equals to negative of H plus K. negative of h plus k or negative of h prime plus k prime, that's equivalent. So if I want to find I prime from equation, then I can do it by simply plugging the value of h and k here, and like that h is 0 and k is -1, so h 0, k is -1. Okay, so 0 minus 1 is again -1, and 0 into -1 is equals to 1. So the index, the third index is 1 actually. So if I have to write the final result for Miller-Bravais indices, then it would be h prime k prime. In some books, prime digits are used for Miller indices, but I am using it for Miller-Bravais indices. Don't confuse with the notations. I have completely shown you people that what I'm meaning, what I mean by these notations. So that is equals to h prime is equals to h, so it was 0. K prime was equals to k, which was 1 bar. I prime is equals to 1 that we have got. Okay, so third index is I prime, so don't forget to follow the pattern. You cannot mix it. Okay, so first we write the index for a1 axis, then we write index for a2 axis, which is k prime, then we write index for a3 axis, which is I prime, then we write the index for L axis, which is Z axis, which is L prime. So yeah, 0 1 bar 1, and L prime is equals to L, which is 1 bar. All right, so that is super easy. In the only difference between the Miller indices and the Miller-Bravais indices for planes in HCP is that there is an additional index, that is I. Okay, that is I or I prime, whatever notation that you are using, which is equals to actually the negative of the sum of a1 index plus a2 index. That is as simple as you can see here. So, and this method will remain the same in any kind of plane that you have got. So first you will find the 3 indices corresponding to a1, a2 and z, and these indices are also the 3 indices in Miller-Bravais indices, and additional index that you have to find out by just by just using this highlighted relationship, in which you have to do this thing, and just the way I have done it. So you will get the third index also, and you will write them in that order. Okay, order of h, k, I and L, and you have successfully solved the problem in that way. This method is only applicable for planes, not for directions. For directions the method is completely different. Okay, you have to find out all of these things separately in case of directions. Today we have found the M index for one of the plane and MB index for one of the planes in here. Now let me elaborate one of the other method that I have told you people, that you can find the A3 intercept, the A3, how you can find out I prime just looking at the figure. That's super easy. You can see here, this line is the positive A3 direction. Okay, I have now drawn it in a straight line. So a straight line, you can see here, this is the positive A3 direction, and this is also a point on the plane. and you can see here the plane is touching the A3 axis as this point, which is a corner of the unit cell starting from origin in positive A3 direction. So the intercept will be 1. Okay, and after finding out the intercept, you take inverse of the intercept. Inverse of 1, okay, is again 1. So 1 is the final index that we would have got just looking at the figure, or you can use that equation that gave you the similar result. So there are the two ways that you can use to find out the indices: by looking at the figure, by using this equation if it is applicable, and there is one other method that you can use, but I will show you that method when it's needed. I have shown that method of using the point intercept form in previous videos. I will link those videos so that you may practice it. But yeah, that is it for the plane in figure 1. Now let's consider the plane in figure 2, and then we'll do it for the plane in figure 3, and after that we will move to directions. For direction part, I will upload a separate video. The reason is the video will become very lengthy because the process of conversion is very lengthy, and I'm using this method of solving it for you people because many of the students find it difficult to understand. Maybe, I don't know. You people must have seen my previous videos where I'm solving these videos on a register. So do let me know that whether this way of delivering the lecture is effective for you people or the other one, when I'm doing it on register by using a pen simply. This type of video is I'm doing it for the first time, and that is why my speed is slow. It will become better with time, I promise. Now let's move to the other problem, and this is the plane 2 in figure 2. Let's see that whether the plane is passing through the origin or not, because you now know the steps. Okay, you now know the steps, or I have to, oh, I just removed those. So you know the steps now. Okay, we first have to define the coordinate system, and after defining the coordinate system we have to find out the intercepts, and after finding out the intercepts we'll take inverse of each intercept. After taking inverse and making sure there is no fraction involved, we have got the Miller indices, and after getting the Miller indices for the plane, we'll find out the Miller bravais indices, in which what we have to do is to find out an additional index, which is I prime, and which is obtained either from the figure or using a simple equation. So that's super easy. Now let's define our coordinate system that gives us such that the plane is not passing through the origin, and the second thing, that it gives you enough information. Okay, the handy one. Yes, this point is good also. All right, because the plane is not passing through the origin. Here the plane is not passing through this origin, as you can see that this point and this point, the points right above this point are this one points. Okay, I'm giving you a justification here that how I can say that this origin is not passing through the plane, or the plane and origin are separated. So I have drawn a point right above this point and this. These are these one points, and if we join these 2 points together just like it's below, you can see here that this is the center most point just above this center point, which is actually the origin. And you can see here there is a distance between this line. Okay, there is a distance between this line and the centermost point. I'm drawing a reflection of what's happening at the bottom plane, just to make you people realize that how I can say that the origin and the plane are separate. Okay, so this is the plane line at the floor. Okay, and here is the origin, and they are separated just the way you can see here. Okay, so we can use the bottom plane as origin. There is no problem at all in taking it as origin, or you can use the this above point as origin also. That's totally up to you. Yeah, that's totally up to you. What's gonna work well? We should take the bottom one, okay, as origin, just to make this problem different from the one that we previously did. You can take the upper point as origin also, but I'm taking the below point, the lower point. So this is origin. Now let's draw the axis lines. Okay, starting from origin and taking this point, okay, this point corner, from origin to this corner, I'm taking it as positive a1 direction. Okay, now we need to find out the positive a2 direction, and for that purpose, leaving this corner untouched. Okay, I hope you can see my green. Leaving this corner untouched, the next corner in order will be the positive a2 direction, starting from origin. Okay, and yeah, this is positive a2 direction. This is a 3D figure, and don't mix that thing that this whole thing is intersecting the plane. No, that's not the point. The plane is intersecting the axis line only on a single point, which will be our intercept. Okay, this is happening here just because it's a 3D figure. Don't mix it. Okay, now let's draw the a3 axis as well, because it's important. I believe that I believe only this is the next corner in order. Okay, this corner is right above this a2 corner. Okay, and the next corner is here, this one. Okay, I hope you can see. The corner right below it is somewhere like here. Okay, and we have to leave that corner untouched. The next corner in order will be at this point right below the point, this one point. Okay, so this is the corner that we will use for drawing the a3 axis, the positive a3 direction. This is the positive a3 direction. Okay, and you can draw the negative directions very easily. Okay, let me draw the negative direction where it's needed. You can clearly see that here's the plane touching the a1 axis at this point. Okay, the plane is touching the a2 axis at this point. I hope you can see where I'm highlighting it. All right, and a1 and a2 intercepts are super easy to find out. Next we have the a3 intercept, and for a3 intercept, what you have to do is to find out the negative a3 direction. So this point is for positive. The corner just opposite to it is this one corner. Okay, so this one corner starting from origin to this corner gives you negative a3 direction, and you can see at which point. Guess. You can guess it well. You can guess it right. This point. Yes, you guessed it right. If you tried to. So yes, this is the point where the a3 where the plane is intersecting the a3 axis. And if you are not good enough to make an estimate that where that point is located, whether it is at middle eye, I am just looking at it, and from my experience I could say that it's half. Okay, because you can see here, this is the complete, from origin to the corner is taken as one, okay, 1 unit length. If it is cutting at the half, just you can see here that this is half and this is also half, equal lengths, these are equal lengths. So this is how I can estimate that it is intersecting at half point. And since it is negative a3 direction, okay, since it is negative a3 direction, so I can say by just looking at the figure at first look that it is -1/2 as intercept of a3 axis. This is something that I can say, but we can confirm it by using that one equation, which was I prime equals negative into h prime plus k prime. So that's super easy also. We'll see it that whether my estimate was correct or not, because I have not solved it before. I'm doing it just in front of you people, so that you may know how naturally I'm looking at the problem and how I'm moving towards the solution. And this is how you can do it as well. And I'm just trying to be as natural as possible for you people. Now for z-axis, that's a bit technical, because I can't see where the z-axis would be intersecting the plane. And for that problem we'll use another method, okay, because two of our methods are not working. The first method was to look at the figure, and if I look at the figure for z-axis, I'm not finding a way to correctly estimate its intercept. So that one method is not working. So second method that we used to do involves this equation, h plus k okay equal plus I equals to 0. This expression is similar to saying that if we take h and k onto the other side of the equation, you simply get I equals h and k are positive here, so they will become negative on the other side of the equation. So this is simply the equation that we previously used, and this doesn't involve L, so you cannot use this equation for determining the z-intercept. So here we got a problem that we are, both of these methods are not applicable here. And what next? What we can do now? So here we can use a third method when we get into the problem that serve as a survivor for us, and that third method is the use of point intercept form. Okay, so the third method that will be used to determine the z-intercept is the point intercept form, and this point intercept form is applicable in every case, whether you are determining the a1 intercept, a2 intercept, or z-intercept. Okay, because for a3 intercept it's not difficult. If you know a1 and a2 intercept, which gives you h and k, alright, so it's very easy to determine I from this equation. Okay, so point intercept form helps you to determine the intercepts of a1, a2, and z axis, so for the plane. And so this method is applicable to all of the cases. As I told earlier, a3 intercept could be easily found from this equation. Here h, k, and I are indices, not intercept. Keep that in mind, okay? Differentiate it from intercept, because intercepts and indices are not the similar thing. Because in order to find out the indices, you have to perform some of these steps on some of the operations, on intercepts, like taking inverse and then removing the fraction. So two operations are performed on intercepts in order to find out the indices. Here the equation h plus k plus I equals 0 is for indices, not for intercepts. So just to clarify it, so we'll use point intercept form to find out the intercept of z axis here. So before that we need to determine the intercepts for a1 and a2. So let's do that. Now you can see this is origin, okay, and this line is the a1 axis. Again I'm saying that, and this is the point. This great little dot is actually the point where the plane is intersecting the a1 axis, and it is actually at the corner of the unit cell, so it will be taken as +1. So we got h we got, sorry, not h for now, we got the a1 intercept to be 1 because it's in positive a1 direction. That is why it is 1. And sometime in the video I just mistakenly said a2 instead of a1, for example. So keep that clear in your mind that that is just by mistake. I'm just showing you people very clearly that what I'm saying. Okay, so I just did it one time maybe in the video at the very start, where I was teaching you people how to draw the axis lines, the negative axis lines, maybe at that point. So yeah, this is the a1 intercept. Now for a2 intercept, you can see this is the point where the plane is touching the a2 axis line. A2 axis line is the this straight line, and you can see that the plane is intersecting it right at the corner of the unit cell. So the a2 intercept is 1. Oh yeah, okay. Z intercept is not known for now, so we'll find it by using the point intercept form. So let us find the z intercept first so that we can move further. These are intercepts, okay, these are intercepts. For now these are not final indices, because for indices you have to perform two functions as I told you earlier. So for z intercept, let us do some additional calculation that is required here. And yes, point intercept form, let me write it. So point intercept form is that we have point on the numerator. Let's say this point is a1 point divided by intercept of a1 for the plane. Okay, so let me call the intercept of a1 axis as a. Okay, or maybe it's better like that it's a, which is okay, a which is a point on the plane, and divided by intercept. Point intercept form, point on the numerator, here a is any point on the plane, divided by intercept, a1 intercept that we have found for the plane, which is 1. Okay, so plus you write b is a point, is any point on the plane corresponding to the a2 axis line. I'll mention it, I'll elaborate it further. Let me first write the formula. B is the point divided by the intercept, which is a2 intercept, so a2 in the denominator, plus c, which is a point on z-axis, divided by the z-intercept, which we z-intercept, so let me write it as z, since these are intercept, and all of these are equals to 1. So this is the equation that we'll be using. And one of the tip, let me first show you that what is ABC. You take any one point on the plane, so maybe it's this one point, okay, this corner point, it could be this point, and the value of and the coordinates of this point will be A, B and C. You will find out the coordinates of this point relative to the origin. And what does coordinates mean? Coordinates mean that how much you have to move along A1, A2 and Z axis in order to reach to that point if you start from origin. Starting from origin, what motions along A1, A2 and Z direction has to be made to reach that point. This is something that we call as coordinates. Okay, so we'll find out the position of that point relative to origin, and these positions will give us the value of A, B and C. Okay, you can take any point on the plane, and that point should be on the plane, okay, not outside of the plane. Okay, so this is another point on the plane. Okay, all these corner points could be taken, any other point could be taken, but make sure that the point you are taking is the one whose coordinates are easily determined. Okay, and what you need to determine should be in your mind also, because one of the important tip is that since I want to find out the z-intercept here, because I'm finding it difficult to find, otherwise I want to find out z-intercept. So one of the tip is that take a point on the plane for which the c coordinate or the z motion is not 0. Okay, so if c is 0, if no motion along z is needed to reach that point, then you have to put c equals 0 here, and this whole quantity will become 0, and the z-intercept will be eradicated or removed from the equation. That is not something that we need, because we want z-intercept in the equation because we want to find it. So make sure that the c coordinate is not 0. If other coordinates are 0, that doesn't matter. Okay, the one intercept you are calculating, it should be taken in mind that its corresponding coordinates shouldn't be 0. So I need to find out the z intercept. That is why I will take a point on the plane that is not on the floor, because at floor where the origin is lying, here is the floor now. This whole plane is origin and it has z equals 0. So I'll take some other point on the plane, and I'm thinking of taking maybe yes, I think I can take this point, D point. I'm taking D point. Okay, and yes, D point is good. So I'll take D point, and I have to find out the coordinates of D point in order to get the value of A, B and C, because A1 is the A1 intercept, which is 1, I know. A2 is here in the denominator, is A2 intercept, that we know is 1 again. So z intercepts need to be determined. A, B, C are determined from the point, and D is the point. Now let us find out the coordinates of D point. Now here comes another technical point to consider in mind. Since I have told you that we are finding out the Miller indices, and this point intercept form only involves three coordinate system, which is A1, A2 and Z. Okay, A3 is not considered at all. So the coordinates of the point, any point that you are considering, should be taken such that the motion only along A1, A2 and Z directions are adopted, while the motion along A3 axis is neglected or avoided. For example, you can see that they are the let me elaborate you this, that this is origin, okay. So these directions are along A3 directions, you can see here, okay. All these directions are not allowed. All right, so because there are the various paths that you can adopt. For example, starting from origin, moving 1 unit along positive A3 direction, then moving upward 1 unit along Z direction, and then moving in this direction, which is actually the positive A1 direction, and reaching to point D. So in this way you can get some coordinates. No, you can't do that. You cannot move along A3 direction at all. So only motion along A1, A2 or Z should be taken, no matter what the magnitude is. So what I'm saying is you can do it this way, that starting from origin, okay, we can move this direction is positive A2 direction, okay, and this direction is negative A2 direction. So starting from origin, if I move -1 unit, because it's another corner of the unit cell, along A2 direction, okay, -1 unit along A2 direction, and from this point onward, if I move 1 unit along Z direction, which is this, I can reach at point D by just moving along A2 and Z direction, and no motion along A1 will be taken as 0 for A, okay, and that's acceptable. Only the motion along A3 directions should be avoided. So the closest path that we could have adopt is this one, where the A3 motion is not considered. So no motion along A1 direction, as you can see. In A2 direction we move -1 unit, so -1, because it is in negative A2 direction, and from that point onward we moved 1 unit from this corner to another corner of the unit cell to reach point D. So the C is 1, positive 1, because it is positive Z direction. So we have got the point A, B and C. Now we have to insert these values right into the equation, okay. This is the equation. Now let me insert all these values right into this equation. Okay, so value of A is 0, so we have 0 divided by value of A1 doesn't matter because it's 0 in the numerator, so we don't need to put the value of A1, and that gives you another advantage. So even if you don't know the expression for A1, you can find out the z-intercept, because the A1 expression will be eradicated. So the expression that you don't know, you can eradicate it by choosing a suitable point on the plane. Value of B is -1, divided by A2, A2 is 1, plus C is 1, divided by Z, which is z-intercept that we need to calculate. That is equals to 1, sorry. Okay, so this expression becomes 0, and that is why I'm not writing it. So we are left with minus 1 divided by 1 is again minus 1 plus 1 over z that is equals to 1. So taking this minus 1 onto another side of the equation, okay, to leave z on one side, okay, so we get 1 over z equals to 1 plus 1, okay, it's negative 1, okay, because it's negative 1 and one side of the equation, and it will become positive 1 on other side of the equation. The operation inverse gets inversed, as you all know. So 1 over z is equals to 1 plus 1 is equals to, say it louder, it's 2. Yes, 1 over z equals to 2. So taking inverse on both sides of the equation, we get, I'm writing it just at the top, 1 over taking inverse on both sides, we get z is equals to 1 over 2. So the z-intercept is 1 over 2. Alright, in this way we have got the z-intercept, which is 1 over 2. Now we have found the three intercepts. A1 intercept was 1, A2 intercept was 1, and z-intercept is 1 over 2. Now we need to perform operations on all three intercepts together. Okay, you can't perform this operation separately. And here we have the z-intercept, sorry, z-intercept is 1 over 2. So these are the intercepts. Now we take inverse of each of the intercept. Write it like that. Taking inverse. Write the operation that you are performing on them. Write it as taking reciprocal or inverse. Okay, taking inverse. So taking inverse of 1 divided by 1. You write the intercept in the denominator. This is how the thing works. And 1 divided by 1 divided by 2, which, okay, if you usually get confused by this notation, you can simply use this one thing as 1 divided by 1 over 2. And you all know that when the division sign is changed by multiplication, the denominator goes into numerator and the numerator goes into denominator, so you will get 2 divided by 1. So 1 multiplied by 2 is something that we got as a result, so 2. After taking inverse, we get 2 here, and here we have got 1 for A2, 1, and for Z we got 2 after taking inverse. And since no fraction is involved, these are the final Miller indices, M indices. Okay, we have got it finally. So H is 1, K is 1, and L is 2. Finally, this is H, this is K, and this is L, and these are H prime, K prime and L prime also, and we need to calculate the the extra index here, which is I prime, and it is equals to negative of H plus K primes over them. Okay, now putting the values into the expression in order to get the value of I prime, which is the 4 index, since now we are finding out the Miller in bravais indices. So it's negative into H prime, which is 1, plus K prime, which is 1 again, and it is equals to negative 1 plus 1 is 2, so minus 2 is the index. Okay, and this is the index. If we talk about intercept is actually the inverse of index. So you know, they are both intercepts. Intercept and index are both are inverse of each other. For example, if you have intercept, you take its inverse, you get index. If you have index, you take inverse, you get its corresponding intercept. So if I take inverse of this index, inverse of minus 2 is minus 1 over 2, and as I told you earlier that I estimated the index here is half, and since it is in negative a3 direction, it will be minus 1 over 2. So its intercept was minus 1 over 2, and if you take the inverse of minus 1 over 2, you get minus 2, and this is something that we got here also. So all in all, I prime index is minus 2, and now we can write out the indices, Miller indices H, K and L. H, K and L is equals to 1, 1, 2. These are the Miller indices for the plane. Okay, and now let us write the Miller bravais indices. And for Miller bravais indices, we have H prime, K prime, I prime. Okay, again I will say the notation is arbitrary. You can use UVWT or UVW, UV prime, W prime, whatever. Okay, it's up to you. The notation that your instructor is using, use that. As I have told you, people, as I have defined every notation in front of you, you can follow your own. So H prime is again equals H, which is 1. Okay, finding out Miller bravais indices from Miller indices is super easy, as you can see. I prime is negative 2, which is 2 and a bar over it to show the negative sign. L prime is equals to L, which is 2. So these are the Miller bravais indices. This is the M index and this is the MB index for the plane 2 in figure 2. Alright, now we'll do it for the plane 3 in figure 3. So this is the plane 3 and figure 3, and I hope that you people are now trained enough to see what's happening in this problem. As you can see that this O point, this position is also a point on the plane. You can see this is the one of the boundary line of the plane, and this origin is not suitable for us, and that is why I'm choosing this one point right above the old origin to be my new region. And so let me define my coordinate system first. Okay, so this is the origin. Okay, now let's define the axis lines and one of the corner. Starting from origin, drawing a straight line. This is positive A1 direction or axis. Okay, leaving the next corner untouched. Okay, this one corner, starting from origin, and here we go. These lines should be straight, as I told you people. Okay, this is A2 axis. Then leaving this third, it's fourth corner actually, leaving this corner untouched. The next corner is point G. From origin to point G is A3 axis. Okay, and for Z axis, this vertically upward is the Z axis, but it doesn't give us any information. I am just drawing it vertically downward because we can see it is passing negative Z axis is passing through the plane or intersecting the plane at point O. It will help us to determine the z-intercept, that is why I'm mentioning it. And yes, so this is how our coordinate system now looks like, and we can see that the A2 intercept and A3 intercept are easily determined. Okay, this point is also a point on the plane. The plane is touching the A2 axis at this is the A2 axis line. Okay, I hope you can see my cursor. Okay, this is the A2 axis line, and at this point, at the corner of the unit cell, the plane is intersecting the A2 axis. So A2 intercept is 1, positive 1 because it is intersecting in the positive direction. And you can see for A3 here. Okay, so this is a point on A3 axis line, and it is also a point on the plane. So the plane is intersecting the A3 axis at this point, which is the corner of the unit cell, and hence the A3 intercept that you have got is positive 1 because it is positive A3 direction. Negative A3 direction is just opposite to it. This is negative A3 direction. Okay, so don't confuse it. Make your mind clear which directions are positive and which are negative. For positive directions, I have shown you a method, and that method will be used everywhere. Okay, you have to use this method, and negative directions are then accordingly selected. There is always a gap of one corner between two positive directions. Okay, this middle direction cannot be positive if these two directions, consecutive corner directions, are positive. Okay, so this is very specific, keep that in mind. A2, A3 and intercepts are known. Now z-intercept is simply -1 because this is origin, and from origin to another corner of the unit cell at the floor. Okay, oh sorry, at the, yeah, it's floor, it's the bottom plane and end of the unit cell, and here is the negative z axis line, and the plane is touching the negative z axis line at this specific point, which is -1. Now let's talk about A1 intercept. So if you produce, this is positive A1 direction and this is negative A1 direction. You can see that the plane is touching here, so let me remove all of these lines so that we may focus. So this one was the negative a1 direction, and at this point the plane is touching the axis line. Okay, you can see the boundary line. So at this point, and this point is clearly half, as I told you people earlier, but I will use an alternative method also, so that even if it is not half, you may use some other method in order to determine it. Let me first write it here as half, and I will derive it using other methods also. Okay, so it's half. If you have seen the previous problems, then it would be clear to you people. You can clearly see that from this corner to this length from this corner to this is 1, and you can see, you can draw vertical lines parallel, okay, to each other. So this is the line, and you can see very clearly this is dividing the whole line into two parts, so it's half. Okay, you can see from this to this length is half, and this is another half. They add up to give 1. So yeah, now let me use some other methods so that you may people may confirm it. We can use the point intercept form here also. This point intercept form is applicable in every case. That is why I'm using it again, so that you may practice it as much as possible, so that you may use it everywhere where you are confused. This equation is magical. It makes process very easy, and even when I was giving my exams, I used to use this equation because it's applicable everywhere. Because the thing that is universal, that could be used everywhere, is something that you should learn, because it will help you in every case. But other things which are occasionally applicable and that gives you a limited advantage, they are not as much trustworthy. So where is my cursor? I can't see. Yeah, I got it now. Now ABC is any point on the plane, and since we want to find out the A1 intercept, so for A1 intercept, the A shouldn't be 0, the point A shouldn't be 0, so there should be a motion along A direction. Now let us take one point on the plane, and do we have to move along? No, this point is not suitable, because for this point from origin you just have to move along A2 direction. No, this is not a suitable point. This point, maybe let us check how we can reach to this point. This is the A1 direction. Okay, keep that in mind. And how we can reach to that point starting from origin without moving along the A3 direction, this is tough to determine actually. So what we can do is, okay, starting from origin we can move 1 unit along A1 direction. Okay, let us see how much motion is needed along each of the direction. So this is a rough work that I'm doing. So along A1 and clearly along z direction we don't have to move at all because it's on the origin plane. Okay, this is our origin and I'm considering here the point G, and for point G you can see it is at the roof plane and we have z point to be 0. Okay, so no motion along z is required because I considered a point on the roof, and at roof we have origin. So with respect to origin, z motion will be 0. So what motion along a1 a2 as a whole is needed? So first I'll move 1 unit along positive a1 direction. Okay, total motion will be taken because I am not. Then we have to move oh yes, now I got it, another method. Yes, what we can do is leave that one point. We can move, this is origin, this is origin, moving minus 1 unit along negative a1 direction. Okay, minus 1 unit, and then from this point onward we can move backward here to reach the point G. Now this point, now this motion, this horizontal motion is in A2 direction. As we can see, this is the positive A2 direction. If we move from origin towards right, this is positive, and if we move in this direction, okay, this is negative A2 direction. So we moved, let me show you again, starting from origin, we moved negative 1 unit along a1 and negative 1 unit along a2 direction to reach the point G. So the coordinates are actually -1 and 0. So these are the values of A, B and C. Okay, these are the coordinates of point G, and they will help us in the direction part as well. So for A we'll put -1 divided by a1. A1 is the intercept that we need to calculate, because I suggested you this method to confirm that the intercept will be -1/2. So we didn't, for now we don't know the value of a1. B is the B coordinate, which is -1. A2 intercept, which is 1, confirmed, plus C was 0, so it will become 0, equals to 1. So we have -1 over a1. This is -1 in this side of equation. We will take it onto the other side of equation. So this -1 will become +1. So 1 plus 1 is something that we get on the right hand side, and 1 plus 1 is equals to 2. So -1 over a1 equals to 2, taking negatives on to other side of equation. And also if we take the inverse, okay, this is taking inverse of on both sides. So 1 over a1 becomes a1, and -2 becomes 1 over -2, which is again -1 over 2. So a1 intercept is -1 over 2. Okay, keep that in mind, that a1 a2, this a1 a2 and z, these are intercepts, not indices. Okay, so the result that you will get is intercept, not indices. Whereas the equation that I mentioned before for a1 a2 and a3 axis relationship, here these are indices, not intercepts. So keep that difference in mind. both of these equations are completely different, and they give you, one of them gives you index and the other one gives you the intercept. So minus 1/2 is the A1 intercept. Now we need to find out the final indices. Okay, and let us find it, because I'm now considering the A1 axis also side by side, because we all know that all these indices are similar in M indices and MB index. Taking inverse of minus 1/2 is -2. Taking inverse of 1, which is again 1. Taking inverse of 1, which is again 1. Taking inverse of -1, which is -1 again. Here we took the inverse since there is no fraction involved here. So these are the final indices. Now we want to find we want to write the Miller index. So Miller index, which are H, round brackets for indices of planes. Okay, for indices of direction we use square brackets, but for planes we use round brackets. So H is the index you get for A1, which we got -2, so 2 with the bar over it. K is the index that you get for A2, which is 1 here, so 1. Then we have L, which is the index that you get for z-axis, which is -1, so 1 with the bar over it. And yes, after that, now we need to write down the Miller-Bravais indices. So these are H prime, K prime, I prime, L prime, and these are equals to H, K and L are same, so we have 2 bar H prime, okay, 1 as K prime. I is 1 for A3, okay, the index you get for A3, which is 1 here, and L prime, which is equals to L, and is 1 bar. And yes, these are the M index, and this is the MB index. For planes, for plane 3 in figure 3. Okay, in this way we have successfully found Miller indices as well as Miller-Bravais indices for the planes in our problem, and in next video we'll be finding out the Miller indices and Miller-Bravais indices for directions, which is totally different from the method that we use for planes. Miller indices and Miller-Bravais indices are very related to each other. They are actually equal to each other. There is one additional index in Miller-Bravais indices that could be found easily by a very simple equation, which is H plus K equals negative of I, or we can say that I prime equals negative of H prime plus K prime. So that is a very easy thing to do, and even there are the problems in which we are given with Miller indices, for example, which is like maybe 2, 3, 4, and we need to convert into Miller-Bravais indices. And since we know that H and K is given, and H and K is also H prime and K prime, so simply using an equation like I prime equals negative of H prime plus K prime, you can simply put right into this equation, and you can find out the value of I prime. And writing them in an order of H prime, K prime, I prime and L prime, you can convert the Miller indices into Miller-Bravais indices very easily. And if you are given with Miller-Bravais indices, you can write them into Miller indices notation for planes by simply removing the I term from them and writing H, K and L only. So this is how these problems can work out for you. And I have also done a problem like these previously I've linked all those problem related problems into the comment section. And yes, for now, goodbye, take care, like, share and subscribe, and do let me know, did you like this video or not. I'll make better videos in future. And yeah, goodbye.